Let's say you have an application where you need an accurate surface temperature reading, but you can't use the surface probe because you can't come in direct contact with the object that you're measuring. Well, that sounds like a job for some infrared sensing technology. Infrared radiation is a type of radiant energy that is invisible to the human eyes, but we can feel as heat. If you take a look at the electromagnetic spectrum, the infrared band sits just outside the range of the visible light. All objects having a higher temperature than absolute zero emit infrared radiation. The hotter the object is, the higher the frequency of that radiation. Infrared temperature sensing devices detect the infrared radiation's frequency and convert that into a temperature reading. There are two types of infrared temperature measurement devices that are widely available today: infrared thermometers, sometimes referred to as IR guns, and thermal imaging cameras, sometimes referred to as thermal imagers. Both work on the same basic principle, sensing an object's infrared radiation and translating it into a temperature reading. But that's where the similarity ends. An infrared thermometer uses a sensor called a thermopile, which turns the incoming infrared radiation into heat using tiny thermocouples. The thermocouples convert that heat into an electrical signal, which is measured and displayed on the screen in the form of a temperature reading. While an IR thermometer is a reliable and cost-effective way to get a non-contact temperature reading, it can only read the temperature for a single point. If you need measurements from a larger area, you'll have to take multiple temperature readings. Meanwhile, a thermal imaging camera like this one uses a focal plane array sensor. This thermal imaging sensor has pixel dimensions of 640 by 480, and with each pixel acting as a sensing element, that gives you over 300,000 individual temperature points on each thermal image or video. Not only does this create a super cool thermal image from the infrared spectrum, you can also store temperature data and use it in any number of ways. And because of its advanced optics, thermal imaging cameras can detect temperatures accurately from much greater distances. And with all this temperature data packed in each thermal image, we can use the analysis tools to highlight specific elements and display their values. And each thermal image or video is saved with a timestamp for reporting purposes. So, if you just need to do some non-contact temperature spot checking and you don't want to break the bank, an infrared thermometer is a good bet. But if you really want to look at the bigger picture for a better temperature profile, then a thermal imager offers a robust sensing, imaging, and recording package. So there you have it. If you have questions, give us a call or chat at omega.com. Thanks for watching, and be sure to like and subscribe.